This is the Slope and Lines tutorial. Let's begin by discussing slope. You may recall slope from Algebra 1. It's expressed as the variable m. And the equation for slope is y2 minus y1 divided by x2 minus x1. Now if you don't recall, y2 and y1 are just referring to the y-coordinates of two different points, points 1 and 2. And x1 and x2 are referring to the x-coordinates of points 1 and 2. So let's practice slope out for one problem. I'm going to create 2 points, point 1 and point 2. Point 1 I'm going to make at 3, 3. And point 2 I'll write in at -4, -2. So let's plot point 1 right now. We'll go over 3 from the origin to the right and up 3 because the x-coordinate comes first. And if you recall, this is the x-axis and this is the y-axis. So that's point 1 right here. I'll put a 1 next to it. And point 2 we're going to plot at -4, -2. So I'll go 4 to the left from the origin and 2 down. And we'll plot a point right there. And I'll label it point 2. Now I'm going to draw a line connecting points 1 and 2 to each other. Now that we have that line, we'll use the slope formula to calculate the slope of that line. And slope is just the rate of change, an elevation. So we call it sometimes rise over run. The rise refers to how much it goes up and down, how much it's rising, and the run is the distance left to right. So slope is just an expression of how much you've gone up or down over how far you've gone left to right. So we'll begin with the y from coordinate 2, which is -2, minus the y from coordinate 1, which is 3, divided by the x from coordinate 2, -4, minus the x from coordinate 1, which is 3. And that's equal to m, the slope. So we'll simplify. -2 minus 3 on top is -5, and -4 minus 3 is -7. I'll simplify further now. A negative divided by a negative is a positive. So this line has a slope of +5 over 7. For every 5 that you go up from one point in the line, you go 7 over to drop a point. Now that we've had a brief introduction into slope, let's talk about how slope pertains to parallel lines and perpendicular lines. Now you may recall that parallel lines are two lines that have exactly the same slope, and perpendicular lines are two lines whose slope is the negative reciprocal of each other. So I'll start by graphing two parallel lines, and then we'll graph two perpendicular lines. So the first two parallel lines, I'm going to start the first line at point -4, -2. And I'm going to give it a slope equal to 3, which you know is really 3 over 1, but we write it as 3. And the second line is going to start at -4, +2, and it's going to have the same slope, which is 3. So recall that if they have the same slope, those two lines must be parallel to each other. So I'll go ahead and graph point 1 and its slope first. Point 1 occurs at -4, -2, so I'll go 4 to the left of the origin and 2 down and drop a point. And we know that it has a slope of 3, so what we can do is go 3 up, so from -2 to +1, and 1 to the right, and drop another point. And we can go 3 up from here, 1, 2, 3, and 1 to the right, and drop another point. So now I'll connect those 3 points into a line, and it looks something like that. Now I'll go ahead and plot line 2. Line 2 begins at -4, +2, right here, and it has an identical slope. So we go up 3, 1, 2, 3, and over 1, and drop a point. Or we could start at that original point, and we could go down 3, 1, 2, 3, and 1 to the left, and drop a point. We went negative in both directions, which is really a negative over a negative, or a positive, to drop that third point. And now I'll connect those 3 points into a line. What you can see with these two lines is that they started at different points of origin, but they had the same exact slope. So they must be parallel to each other, and they look like they're running exactly parallel to each other. They're never going to intersect. Now let's talk about perpendicular lines. Perpendicular lines are two lines whose slope is a negative reciprocal of each other. So if we had the first line here, and it had a slope, or excuse me, a origin point of, let's say 3, 2, and it had a slope of 3 over 1, and then we had a second line, line 2 here, and line 2, let's say, begins at 2, negative 2. And its slope is the negative reciprocal of the first line, so negative 1 over 3. In theory, these two lines are going to intersect perpendicularly to each other, so let's plot them both out and double check. Line 1 begins at 3, 2, so we'll go over to the right from the origin 3, and we'll go up 2, and put a point. And its slope is 3 over 1, so I can go 3 up from this point, and 1 over, and drop a point. And I could also go 3 down, and 1 in the opposite direction to the left here, and drop a point. Now I'll connect those 3 points into a line for you. Now that we've graphed line 1, let's graph line 2. Line 2 begins at 2, negative 2, and its slope is a negative 1/3, so I can go down 1 and 3 to the right. Or I could go up 1 and 3 to the left from that point. And I'll put a line through there for you. So now you can see line 2. Next I'm going to extend the first line, the red line, to meet the black line there, because you know as a line it goes forever in both directions. Now that I've extended that line, you can see that the red line and the black line intersect each other at a 90-degree angle, which is perpendicular. So that's how you deal with slope in relation to parallel lines and perpendicular lines. Pay attention to the slopes to see if they're exactly the same, or if they might be the negative reciprocal of each other.